Hi everyone, I am Pariti Kumari of EC department. Today we learn about Boolean algebra and logic gates. So binary digits. What are binary digits? 0 and 1. Computer can only understand 0 and 1. 0 represents off, false and low value. Whereas 1, it represents on, true and high value. So Boolean algebra. So there are various operations in Boolean algebra like addition and multiplication. So for addition, 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1 and 0 plus 0 is 0. In case of addition, if at least one of the input is high, so output will also be high. Whereas in case of multiplication, 1.1 is 1, 1.0 is 0, 0.1 is 0 and 0.0 is also 0. In case of multiplication, the only condition the output is high if all the inputs are high. Further concepts of Boolean algebra, addition of binary digits. For addition of binary digits, let's say A can be 0 and as well as A can be 1 also. So according to properties of 1, A plus 1 is A. That is, if A is 0, so 0 plus 1 will be equal to A plus 1 is equal to. So properties of 1, A plus 1 is equal to 1. For let's say if A is 0, so 0 plus 1 is equal to 1. That is again A. And if A is 1, so 1 plus 1 is 1. For multiplication of binary digits, let's say A is 0 and A can be 1 as well. So A dot 1 is A and A dot 0 is 0. That is, if A is 0, so 0.1 will be equal to 0, that is A. And if A is 1, so 1.1 is equal to 1, that is A. And in the next case, if A is 1, so 1.0 is equal to 0. And if A is 0, then 0.0 is also 0. So now we'll study about the inverse concept. That is, if we provide low input value, then we'll get high input value. And similarly, if we provide a high input value, that is 1, high input, so we'll get low output, that is 0. Further, we'll study about De Morgan's law. The expression for De Morgan's law is A plus B bar equals to A bar dot B bar, or A dot B bar, A bar plus B bar. A simple trick to learn De Morgan's law is break the line and change the sign. So we'll see the proof of De Morgan's law. LHS A plus B bar. So let A equals to 1 and B equals to 0. So A plus B, that is A plus, since A is 1, so 1 plus and B is 0. So 1 plus 0 is 1. And A plus B bar, that is inverse of it, it will be 0. And RHS is A bar dot B bar. So since A is 1, so A bar, that is inverse of A will be 0 dot, and B is 0. So inverse of B, that is B bar, it will be 1. So 0.1 will be 0. So hence LHS is equal to RHS, proved, and the expression A plus B bar equal to A bar dot B bar, it is verified. So now we'll study how to draw truth table for any component system, for 2 components, for 4 components, etc. So for two component system, let's say A and B, and the operation is OR A, B, output is Y. So since there are two components A, B, so there is a formula for number of entries. So that is 2 to the power of n. So since there are two components, so 2 square 4, there will be 4 entries, and the entries will be like this: 0 0 1 1 0 1 0 1. And from OR operation, so y is equals to A plus B. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. And for, let's say, three component system, n will be equal to 3. So 2 to the power of 3, that is 8. So the number of entries will be 8. A, B, let's say C, and this is Y. Again we are performing OR operation. A, B, C. A plus B plus C. So the number of entries are 8. So 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. So we have to do OR operation, that is A plus B plus C. So 0 plus 0 plus 0, it's 0, 0 plus 0 plus 1, 1, 0 plus 1 plus 0, 1, 0 plus 1 plus 1, 1, 1 plus 0 plus 0, 1, 1 plus 0 plus 1, 1, 1 plus 1 plus 0, 1, and 1 plus 1 plus 1, 1. So basically in the OR operation, this is how you plot a truth table. And since it is an OR operation, so at least one of the inputs should be high so that the output is also high. So now we'll study about logic gates. So what is the purpose of logic gates? So we use logic gates to allow electrical signals or to block electrical signals to enter into the circuit. So what are logic gates? The digital devices which perform Boolean function by taking input and giving output. So these are basically devices which takes input and give output, and the logic gates are based on Boolean algebra, and they are made up of diode and transistor. There are various types of logic gates. So the basic logic gates are OR, and NOT. So OR gate, the symbol for OR gate is like this. This is input side, there is output side. Let's say input is A, B, and output is Y. So the expression will be A plus B. OR is denoted by plus sign. And for AND, the symbol is like this. This is input, and this is output. Y equals to A dot B. This is denoted by dot. And for NOT, this is A. It is the inverse of A, that is Y equals to A bar. So further we'll plot the truth table for OR, AND, and NOT. So for OR, since it is a two component system, A and B, the number of entries will be 4. So A, B, 0 0 1 1 0 1 0 1. And Y, that is A plus B. So 0 plus 0 will be 0, 0 plus 1 will be 1, and 1 plus 0 will be 1, and 1 plus 1 will also be equal to 1. Since in OR gate, at least one of the inputs must be high for output to be high. And now we'll plot truth table for AND gate. A, B, Y. So 0 0 1 1 0 1 0 1, 0 dot 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, and 1 dot 1 is 1. So in this, high input is obtained only when both A and B, they are high. They are 1. That is, they are high input. So therefore, high for both A and B, both are high, then only high output is obtained. For NOT gate, this is an inverse gate. Means if we A Y. So if input is 0, output will be 1. If the input is 1, the output will be 0. Basically, it gives in the inverse value of the input. Now we'll study about universal gates. So NOR and NAND, they are known as universal gates because they generate any logical Boolean expression, and other gates, basic gates and OR and NOT, they can also be created using NOR and NAND gate. So the symbol for NOR gate is, simply we'll draw an OR gate and then we'll put a circle in front of it, A, B. Basically it is the inverse of OR gate. So to draw the truth table for NOR gate, A, B, let's say this is A plus B, and NOR gate, it is an inverted OR gate. So A plus B bar. This is the output. It is A plus B bar. 0 0 1 1 0 1 0 1. So for OR operation it will be 0 1 1 1, and since NOR gate is inverted OR gate, all the 0 will become 1 and 1 will become 0. So this is NOR gate, the truth table for NOR gate. Similarly for NAND gate, it is the inverted AND gate. So inverted AND gate, let's say A, B are the input, and for a NAND gate the symbol is same as AND gate, except one circle is placed here and the output is A dot B bar. Now the truth table for NAND gate, let's say this A, B, this is A dot B, and the output, that is A dot B bar. 0 0 1 1 1 0 1. A dot B 0 0 0 1, and so for A dot B bar, 0 will become 1 and 1 will become 0. So this is NAND gate, the truth table for NAND gate. Furthermore, there are two more gates, XOR and XNOR. This is known as exclusive OR gate, and XNOR, it is simply the inverted XOR gate. The symbol for XOR gate is, we'll draw this OR gate and then we'll draw simply a curve like this. Here input A, B, and this is output. The symbol for XOR gate is a plus with a circle. And now to plot the truth table for XOR gate, and the expression for Y will be Y equals to A B bar plus A bar B. A, B. Need not to write A bar and B bar, but for explanation purposes I am also writing A bar and B bar. 0 0 1 1 0 1 0 1. So A bar will become 1 1 0 0, B bar will become 1 0 1 0. So let's write A B bar also and A bar B also. So A B bar, this is dot sign, we have to do multiplication. So A B bar 0 dot 1 will be 0, 0 dot 0 will be 0, 1 dot 1 will be 1, 1 dot 0 will be 0. A bar B, so 0 dot 1 will be 0, 1 dot 1 will be 1 will be 1, 0 dot 0 will be 0, and 1 dot 0 will be 0. Now we have to add these two expressions. This is the output. So 0 1 1 0. A simple trick to learn the output is, if there are even number of zeros, let's say here there are 2 zeros, so the output will be 0, and in the last there are no zeros, that is even, that is 0, 0 times 0, so it will be 0. It is simply a trick, nothing related with the logic of the expression. And for now, XNOR gate, the inverted XOR gate. So similar, we have to draw similar drawing as XOR gate and then put a circle in front of it. It's A B Y. and the symbol for XNOR gate is A dot in a circle and B. The truth table A B Y 0 0 1 1 0 1 0 1. So since XNOR gate is simply inverted XOR gate, so we have obtained the value for XOR gate. Simply we will reverse it. For 0 it will be 1 and for 1 it will be 0. So 1 0 0 and 1. So this is the truth table of XNOR gate. So now we'll study about the use of NAND gate to create AND gate, OR gate and NOT gate. So since NAND gate is a universal gate, so we can create other gates using this gate. So for AND gate, it will be drawn like this. The circuit will be like this. A and B are input, so here it will be A dot B bar, and if we place another AND gate, so it will become A dot B bar, then again bar. So A bar is equal to A. The complement cancel each other. So it is A dot B. So these two NAND gates, when placed in the given position, so it works as a AND gate. Further, for making OR gate, so this will be the circuit. Here it will be A bar, here it will be B bar, and here it will be A bar dot B bar dot this, and again a bar. So here we'll apply De Morgan's law, break the line and change the sign. So it will be A double bar plus B bar and double bar. So it will become A plus B. So here this circuit, it will behave as OR gate, and for NOT gate, simply it will be like this. For example, A, so it will return A bar, A complement. So to summarize, we have learnt about binary digits. Then we have learnt about addition and multiplication of binary digits. Then we have studied about truth table and few laws like inverse law, then De Morgan's law. Then we have further studied about what are logic gates and types of logic gates. Then we have studied about the creation of OR, AND NOT gate using NAND gate, which is a universal gate. Thank you.